Hello and welcome back to differential equation. This is lesson 3, and in today's lesson we are going to be talking very briefly on some topics which we are going to see as we progress. So last week we looked at some types of differential equation. We look at the methods we use in solving them. And okay, let me first thank you guys for your participation during the WhatsApp class. You guys are awesome. Thank you very much. And last week we talked about a particular type of differential equation and the way we do solve them. So far we've looked at first order linear differential equation. We look at the one that involves logarithms, the one that involves sines, and today we are going to start with linear differential equation. Then if time permits we move to binomial equations. Just I want you to pay right attention to this course. It might be a little bit tricky, but if you follow the class very well you are going to get it quite simple. So before we proceed fully into the course, let's talk about some definitions of what we are going to be using later in the course. And don't forget that I said what we are going to be considering is linear differential equation. So the first definition we have here is that any equation in the form dy over dx plus py equals q, where p and q are constants or functions of x only, is called a linear differential equation. Actually, I'm going to give some examples to illustrate this. The definition proceeds by saying this type of equation cannot be solved by different direct integration, but it has been discovered that if such an equation is multiplied by some factor, e raised by integral of p dx, called integrating factor, the resulting equation can be solved easily. And please, let's take note of this. We are going to be using it very well during the course of the lecture. So now to elaborate this definition, I bring out this formula. The definition says any equation in the form dy over dx plus py equals q, and this is the equation. And we're told here that it has been discovered that this equation will be multiplied by what? By integrating factor, which is e raised by integral of p dx. Now, if you multiply both sides by this, by e raised by integral of p dx, you get this. Let's take note of this very well. If you multiply everything here by this, you get this. So the next thing is just to integrate the equation 2 with respect to dx, and we get this. And this is quite simple. We are integrating equation 2 with respect to dx here, no more dy. So integrating this still gives us this again. You should know that integrating e is for integral of p dx still gives us the same thing. And if we integrate this with respect to x, we get what? Y. Now the integral of this is still left there. So this is what we are going to be using majorly during the course. So during the course of the lecture. So example 1, the question says solve the linear differential equation dy over dx minus y cos x equals e raised power of sine of x. Now the first thing we have to do here, I was saying the other time that we have to pay very rapt attention to this lecture. So the first thing we have to do is to compare with what we have in our equation from our definition. And don't forget we have this particular equation from our definition. So we have to compare our given equation, which is this, compare it with what we have in our definition. And from here we can have that p from here, which is equal to what? Minus y cos s, and our q is what? Q here, which is what? Q here is e sine of x. Now we multiply both sides by e raised power p, then we multiply both sides by e raised power integral of p dx. You should not forget this is a constant we have to multiply the equation with. So this is not being brought from anywhere, it's a constant. You have to multiply the equation with both sides. Then if you do that, we get this. So if you multiply this by e raised power of integral of p dx and the other side by also this, we get this. So the next thing is to integrate both sides. Now integrating both sides, we have this is just the expression of the integration. We have integral of this for all the left hand side, integral of all this equals what? Integral of what? The second part, which is this. Now before you proceed, let's evaluate integral of p dx, and I quickly do that here. That integral of p dx equal to integral of minus cos s, as soon as p is what? P is minus cos s. So we have p here, which is minus cos s ds, which is equal to what? Minus sin x. Now we can now introduce that to our equation, that integral of what? E raised power of what? P dx. We should not forget integral of p dx is what? Minus sin x from here. So we have integral of e raised power minus sin x. This still comes back here equal to integral of what? E. This still comes back here, and we have e minus sin x, which comes from it from here, which is integral of what? P dx. So this is what we have. Now if you integrate this side, the left hand side and the right hand side, we get y e raised power minus sin x, because this is not being integrated. The same thing is still being brought down back. Now don't forget we are integrating with respect to x. That's how you have to get this. Don't forget, if you integrate everything here, because we are integrating in respect to x, we get y. And if you integrate e raised power minus sin x, we still get the same thing again. That's one of the constants in integration and differentiation too. So we can actually sum this here. This y e raised power minus sin x equals what? Integral of dx. Now how do we arrive at ds? You should not forget, from indices, everything here turns to 1, because this is sin x minus sin x, which turns to what? 0, and into this by 0 equal to 1. So here we have integral of what? Dx. Now if you integrate the other part, if you integrate this, we get what? X plus the constant of integration, and this thing now, this part also comes down as it is. Now we can now draw out our final answer, which is equal to y equals to x plus c e raised power 40 sin x. This y. Now if x was 3, this at the other side, and this we divided all through by e raised power minus sin x. Also divide this side by that, we are going to arrive at what? E raised power what? Sin x. And that's that for example 1. You should try to follow through. It's very simple. After we compare our equation, we have to multiply through by e raised power of integral of dx, then we integrate, just like we are doing when we are separating variables in the previous tutorial. Now this is example 2, and the question says solve the linear differential equation dy over dx plus 3y equals e raised power of 4x. This is very similar to the previous example we had, and it still follows the same procedure. Don't forget the first thing is to compare. After that, we multiply through by e raised power of integral of p dx, then we integrate both sides. So let's start by comparing, as I mentioned earlier. So we compare this equation, which is our given equation here, with what we have in the definition, which is this. And from here we can draw the value of our p, which is equal to 3 from here, and our q, which is equal to what? E raised power of 4x. So the next thing is to multiply through by e raised power of p dx. Now if you multiply through by e raised power of p dx, we got this. As you can see, this is e raised power of p dx. Everything here comes down as it is. This comes down as it is, and this is what we are multiplying by, which is e raised power of p dx. So now we integrate both sides as usual. Now integrating both sides, we have this expression, like integral of this, integral of this, and the integral of this, and this is exactly what we have here. Now it's necessary for us to draw out what the value of integral of p dx is. That's how I draw it out here. So we have the integral of p dx to be equal to what? 3x. Don't forget we have our p, which is equal to what? 3. So that's how we have integral of 3 dx here, which is equal to what? 3x. Now we integrate. After we substitute our value for integral of p dx, we integrate. So this is integral of e raised to the power of 3x. Where do we get the 3x, which is from a? You should not forget integral of p dx equal to what? 3x equal to what? Integral of e raised to the power of 4x, which is a multiplied by e raised to the power of 3x. So this is what we have. Now integrating in respect to x. I'm mentioning, don't forget this in respect to x. So if you integrate this in respect to dx, we have y, everything here becomes y, and this still remains the same as integral of e raised to the power of 3x still remains the same thing. Then we are integrating this, the value is brought down again without being integrated. Now we have y e raised to the power of 3x equals integral of what? E raised to the power of 7x. Where do we get the 7x? Through indices. After we have already what? Add the powers once the base is the same. Now we simplify our expression further. You can simplify this. After integrating this, we get this plus what? The constant of integration. Now we can simplify y further to get the value, the full value of y, which is, after we divide through by e raised to the power of 3x, we get y equal to e raised to the power of 4x divided by 7 plus c, which is the constant of integration, e raised to the power of minus 3x, and which is the answer. Okay, thank you guys very much. That's it for this tutorial, and we're going to be talking fully the next time we are meeting. I want us to bring all our questions to the group chat. If there's any question, any question you can answer, please do. We are going to meet. It's going to be a very brief meeting the next time because the lecture is even very brief. Thank you very much.